Hello students, welcome to Solochem Lab. On the board today, there is a 2021 UTME problem that we want to look at. The problem starts with an equation of a reversible reaction. Did you notice this double arrow here? One is pointing to the right, that's to the product. The other one is pointing to the left, that is to the reactants. Each time two arrows are used like this in a chemical equation, it shows that that reaction is reversible. It can proceed in the forward direction to give us the products. It can also proceed in the backward reaction to give us the reactant. Did you notice the delta H value here? The delta H value here is positive. This letter H implies enthalpy of the reaction. And enthalpy means the heat content of either reactant or the product. And whenever we have delta H, it means the change between the heat content of the product and the heat content of the reactant. Do you understand? And when the delta H value is positive, it means that the forward reaction is endothermic. An endothermic reaction is a type of reaction during which heat is absorbed into the reaction system. Heat is absorbed into the reaction system. And how you know that heat is absorbed is when you fill the beaker or the test tube or the reaction container. At the end of the reaction, the container feels cold to show that heat is absorbed from the surroundings into the reaction mixture. But when you dissolve, let's say, sodium hydroxide in water, and you fill the container, you fill the beaker, you notice that the beaker feels warm, meaning that heat is given out to the surroundings. And that is an example of exothermic reaction. And an exothermic reaction, the delta H value is not going to be positive, it's going to be negative for exothermic reaction. But the reaction on the board is an endothermic reaction because of this delta H given to us here is positive. That's for the forward reaction. That implies that the backward reaction will be exothermic. Do you understand? The backward reaction will be exothermic. And the problem goes this way. In the reaction above, an increase in temperature what will an increase in temperature do? Some options are given here, and you are expected to select the right option. If the forward reaction is endothermic, that means it likes heat. Heat is absorbed into the reaction system. It means at higher temperature, that's when the temperature is increased, the forward reaction will be favored. Do you understand? Favoring the forward reaction means that product will predominate. More products will be formed. And if more products are formed, do you know what will happen to the equilibrium constant? Look at this place. You'll see how equilibrium constant is gotten. It's gotten by the concentration of the product, which is here, the NO2, nitrogen 4 oxide, put in square bracket, raised to power 2. This power 2 is the coefficient that we have here that helps us to balance the chemical equation. Do you understand? Divided by the concentration of the reactants, which is this, in square brackets, raised to power, what's the coefficient here? The coefficient that is here is 1. So the power here is 1. It is understood to be there, we do not write it. The same way the coefficient here is 1 and we do not write it. Do you understand? So whenever we have more of the products formed, it means the value of the numerator here will go up, will increase. And when the value of the numerator increases, it means the value of the equilibrium constant will increase. Do you understand? That is when more of the products, when we have more of the products here. So let's look at the options. In the reaction above, an increase in temperature will, option A says, increase the reactant production. If you increase the temperature, the reaction itself, the forward reaction is endothermic. That means it likes heat. Heat is absorbed into the reaction mixture. And option A says the reactant production. Increase in the reactant production. This is not correct. Because when you increase the temperature, you are favoring the forward reaction. And forward reaction is product formation. So this is wrong. Increase in temperature will not increase reactant production. Do you understand? Then option B says, an increase in temperature will increase the value of equilibrium constant. To increase the value of the equilibrium constant means that the numerator here, the value is going to increase, going to become more. And for this value to become more, it means more of the products, we have more of the products produced. And that is what is going to happen. Do you understand? So option B is the correct option. Let us also look at option C, which says shift the equilibrium to the left. This reaction is endothermic. It likes heat, the forward reaction. Now when you increase the temperature, is it going to favor the backward reaction when the forward reaction likes heat? No. Shift the equilibrium to the left means moving the reaction to the left. And that is wrong for this particular equation on the board. That is not the correct option. And then the option D says decrease the value of the equilibrium. Decreasing the value of the equilibrium constant here means decreasing the production of the products. And that is not what we have. Making this smaller and this bigger. No, that's not what we have here. So option D is not correct. The correct option here is option B that says in the reaction above, an increase in temperature will increase the value of the equilibrium constant. How will it do that? It will do that by shifting the equilibrium position to the right, favoring product formation. And when it favors product formation, this expression of the equilibrium constant here tells us that the value of the value of K will be increased because the concentration of the product, which is the numerator, is going to go up, and then the concentration of the reactant will be going down, making the value of the equilibrium constant to increase. Therefore, option B is the correct option. Do you understand the explanation? Do you still need more explanation on any topic in chemistry? Do not forget to contact Solochem Lab at this. Do not forget to contact Solochem Lab using this. We'll see again later in subsequent classes.